Hello everyone and welcome to another episode on this very channel. In these very tutorials, we want to see how best we can approach a question of this very form. Remember, we are still on the same topic, probability, and we are looking at compound events. If you haven't subscribed to my channel, kindly hit on the subscribe button for me. So let's get started. But before we look at this question, as I said in my previous video, to be able to understand and solve questions on compound events, then you should be able to understand the multiplication law. You should also understand the addition law and the complementary rule, because this plays a key role in compound events and we are going to make use of them frequently. Fortunately for my students, I have done a very detailed video lessons on all of these three rules and laws of probability. If you haven't watched them, kindly go back and watch them before you start looking at these particular questions on compound events. So let's look at this question. It reads, the probability that Ato hits a target is given as 3 out of 5. And then the probability that Oko also hits a target is 2 out of 3. If they both shoot together, what is the probability that A, both of them hits the target, B, none of them hits the target, C, one of them hits the target, and D, at least one of them hits the target? So we want to find the probability of all of these events. We are saying that the probability that Oko and Ato hit a target are given in the question, and we want to find the probability of these events. So first thing that we are going to do is to use any variable at all to represent Ato and then Oko. So let's use A for Ato, and then let's use O for what? Oko. And we are saying that the probability that Ato hit a target is what? 3 over 5. So we can write it as probability that Ato hit a target is what? 3 out of 5. We also said that the probability that Oko hit the target is what? 2 out of 3. And this is where it can be found. If you can't see it clearly, that is 2 out of what? 3. We want to find the probability that both of them hit the target. Now, when we talk about both of them, we are referring to the probability that Ato hits the target and Oko also hits the target. So the word or and then and plays a key role in compound events. If you don't understand how to make use of the or and the and, you always find yourself wanting. So with both of them hitting the target, it means that Ato was able to hit the target and Oko was also able to hit the target. So we can write it as, so we have our first one, probability that Ato hit the target and Oko also hit the target. Now we said that the word and is the same as what? The intersection, and it corresponds to the multiplication law. So from this, we can write it as the probability that Ato hit the target and Oko also hit the target. This n means the intersection. Now once we have this, we apply the multiplication law of probability. So we are going to have probability that Ato hit the target multiplied by the probability that Oko also hit the target. So what we are going to do here is to substitute in their corresponding probabilities. probability that Atu hits the target is 3 out of 5. So we have 3 over 5. Oku, we have 2 over 3. And when you do your multiplication, you are going to get 6 all over what? 15. When you simplify, you are going to get what? 2 all over 5. So the probability that both of them hit the target is what? 2 out of 5. Very, very easy and then simple. Let's look at B. The probability that none of them hit the target. We are talking about what? None of them. So it means that Oko was not able to hit the target and Ato also was not able to hit the target. It means none of them targets. So we have probability that Ato was not able to hit the target and Oko also not able to hit the target. We are using the bar to represent the complement of Ato and Oko. It means that Ato was not able to hit the target and Oko also was not able to hit the target. So we are using the bar to represent complement. In some books, we are going to use this or that. It means the same thing, but we are using what? The bar to represent the complement of Ato and Oko. So we can write it as the probability that Ato was not able to hit the target and Oko was also not able to hit the target. Since we are having the intersection which represents the multiplication rule, we are going to write this as the probability that Atu was not able to hit the target multiplied by the probability that Oko was not able to hit the target. So before we can find this probability that none of them hit the target, then we should be able to find the probability that Atu was not able to hit the target. Then we find the probability that Oku was not able to hit the target. They multiply their probabilities together. So we know that from the complementary rule, the probability of an event occurring, let's use the Atu on, plus the probability of that event not occurring should give us what? 1. So from here, you can say that the probability that Atu was not able to hit the target will be given as 1. Then we transpose this to the right-hand side to obtain this. So the probability that Atu was not able to hit the target will be given as 1 minus this. We have 3 all over 5. And when you do your subtraction, you are going to get what? 2 all over 5. Now from this, we can also see that the probability that Oko hit the target plus the probability that Oko didn't hit the target is equal to 1. So we have probability that Oko didn't hit the target is equal to 1 minus probability that Oko hit the target. So Oko hit the target, we have 2 over 3. And this is going to give us what? 1 all over 3. So probability that Ato didn't hit the target and Oko didn't hit the target is giving us P of A prime. So we have P of A prime, we have 2 over 3, 2 over 5, sorry, multiplied by P of O prime, and that's 1 over 3. So when you do the multiplication, you are going to get 2 all over 15. So the probability that none of them hit the target is 2 out of. Let's look at the next one, which is the probability that one of them hits the target. So probability that one of them hits the target will be given as it is. So we have probability that Ato hit the target and Oko couldn't hit the target. Or we can have it as or probability that Ato couldn't hit the target and Oko was able to hit the target. We are looking at one of them was able to hit the target. So we are having to Ato and Oko. So it is either that Ato was able to aim and hit the target and Oko missed the target or couldn't hit the target. Or it can happen that Oko couldn't hit the target and it can happen that Ato couldn't hit the target and Oko was able to hit the target. So with this, we are having the intersection or the end. We are going to make use of what? The multiplication rule. So we can expand this and write it as probability that Ato hit the target multiplied by probability that Oko couldn't hit the target. The all in probability means what? The addition. And then we have probability that Ato couldn't hit the target. The n means multiplication. Then we have probability that Oko hit the target. Now once we have this, we substitute in their respective probabilities. P of A, we had 3 over 5 multiplied by P of O prime. P of O prime, we had 1 over 3 plus P of A prime or A complement, we have 2 all over 5. P of O, we have 2 all over 3. So when you do your multiplication, you are going to get 3 all over 15, and then we have plus, this is going to give us 4 all over what? 15, and this is going to give us 7 all over 15. So the probability that one of them hit the target is 7 all over 15. Very, very easy. Let's look at the last one. At least one of them hit the target. Let me write this one here. So we have probability that at least one of them hit the target. So at least one of them hitting the target means that one of them should hit the target or two of them should be able to hit the target. So we have one of them hitting the target or two of them hitting the target, and that is going to give us at least one of them hitting the target. So with that, we can use the complementary rule to help us find this. We can also use the addition law to help us find this, and then we are also going to use another approach to also help us find the probability that at least one of them hit the target. So let's use the complementary rule. So with that, we are going to have 1 minus the probability that none of them hit the target. So with the complementary rule, we said that the probability of an event occurring plus the probability of that event not occurring should give us 1. So the probability that at least one of them hit the target plus the probability that none of them hits the target should give us 1. So if we are looking for at least, then we have probability that at least one of them hit the target will be equal to 1 minus, then we transpose the whole of this probability that none of them hit the target. That is how we came about it, using the complementary rule. So we have 1 minus none of them hit the target. So I think we have already looked at that one. So this is none of them hitting the target. And then we had 2 all over 15. So we have 2 over 15. When you do your subtraction, you are going to get 13 all over 15. So the probability that at least one of them hits the target is what? Let's use the addition law. So with the addition law, we have method 2. Probability that Ato hit the target union Oko hitting the target will be given as probability of A plus probability of O minus probability of A intersection of O. Ato hitting the target, we had 3 over 5. Oko hitting the target, we have 2 all over 3. Minus Atu and Oko hitting the target, we had 2 all over 5. When you do your addition and subtraction, you are going to get 13 all over 15. Let's look at another approach. We have method 3. So probability that at least one of them hit the target, so it means that one of them should hit the target. One of them should hit the target, or the 2 of them should hit the target. So we are going to have probability that Ato hit the target and Oko missed the target, or probability that Ato missed the target and Oko hit the target, or probability that Ato and Oko hit the target. And this is going to give you at least one of them hitting the target. At least Ato here is hitting the target. Here Oko is hitting the target. It means one of them should hit the target, or 2 of them should hit the target. And this is going to give you the same answer. So we can expand this and write it as probability that Ato hit the target. The N means multiplication. Then probability that Oko missed the target. The O means the addition. And then we have P of A prime. And then P of O plus P of A multiplied by P of O. Probability that Ato hit the target, we had 3 over 5. Oko missed the target, we had 1 all over 3. Plus Ato missing the target, we had 2 over 5. And then Oko hitting the target, we had 2 all over 3. Plus both of them hitting the target, so we have 3 over 5 multiplied by 2 all over 3. So when you multiply this, we are going to get 3 all over 15 plus this will give you 4 all over 15. We had this is going to give you 2 all over, okay, let's make it 6 all over 15. So when you add all of this, since the denominators are the same, we can pick one of the denominators, we add the numerator. This is going to give us 10 plus 3, we have 13. So we have 13 all over 15. So we can either use the complementary rule, we can also use the addition rule, and then we can also use our intuitive understanding of probability to help us solve for at least one of them hitting the target. This brings us to the end of today's lesson. If you haven't subscribed to this channel, as I've been saying, kindly hit on the subscribe button for me. This has been your tutor, Asamoah. See you tomorrow. Bye bye.